Hi everyone, this is Satish Hooli. So today we are going to see regarding few problems regarding pumps. Okay, so it is in the model 5 in WSTE subject itself. So we'll start with the problem itself. So in the problem what he has given, so he has stated that a centrifugal pump which is being driven by an electrical motor lifts the water from a total height of 50 meters from the reservoir to discharge uh, at the end. Okay, the pump efficiency is around 77% and the motor efficiency is around 85%. The lift is through 300 meters length and a 10 centimeter diameter pipe, and the pumping rate is around 1500 liters per minute, and H4 equals to 0.025, and the cost for pumping 4 million liters. What is the cost of pumping for 4 million liters? So when you have gotten power cost around 25 paisa per kilo hours. Okay. So per kilowatt hours. So in this problem, what he has given the H, what he has said that the total height that is 50 meters. So this consists of HS plus HD. It doesn't consist of HF. Okay. So in the previous thing you can see that uh, the total head loss equals to what, that is HS plus HD plus HF. So you need to find out here what is an HF. So HF is nothing but head loss due to pipe friction. So it is given by this equation, that is F dash L V square by 2 GD. So it can, that equation can be rewritten in this sense itself. Okay, so now HF is nothing but H4F, so that is been given as 0.025, L is nothing but 300, and D is nothing but 0.1 meters, and Q is nothing but it is 1500 liters per minute, which has been given in this problem itself. So 1500 divided by 60, you will have in terms of cubic meters, so that is 0.025 cubic meters. Okay, that is Q. So what we are doing here is we are substituting all the terms in this equation. So at the end we have got an HF equals to 38.77 meters. So now the total head is nothing but, now what happens here is 50, that is what, as I stated earlier, that is HS plus HD plus HF. So SH plus HD is 50 and HF is nothing but 58.77. So as we have stated here itself. Okay. Now, so that is H. So H is around 88.77. Okay. So now what we are doing here is we are using a power equation. So this power equation, we can see that in the previous where I have stated, here we have got an work done equations. Okay. So horsepower equations, water horsepower equation, that is been given here itself, and the brake horsepower equation. So with these equations has been stated in the theory part itself. Okay. Now what we are doing is we are using that equation. So first we are finding out an water power value. So first what we are doing is we are putting rho WQ into H. So rho W is nothing but 9.81. Okay. So Q is nothing but 0.025, which we have found it earlier itself. So H is nothing but 88.7. So this is H 88.7. So that will be the value around 21.77. So 21.77 divided by 0.735. So that is nothing but 1 HP is equal to 1 kilowatt. So here that thing has been stated over here, this one. So we can see this equation. Okay. So we have put it that 0.735 kilowatts. That value that is there in that equation itself. So that one we have been substituted. So you're getting in water horsepower at as an 29.62. Okay. So that the water horsepower is divided by efficiency, you'll get in horsepower. So efficiency, there are two types here. One is in motor efficiency, one is in pump efficiency. If they have given only one efficiency, you should have taken that only. But here they are given in terms of both power, pump and as well as motor itself. So divided by that efficiency, you will get the horsepower, that is 45.26. So that 45.26 into kilowatts, you will get the total power requirement. So 45.26 into 0.735, When you do it, you'll have the total power requirement. Okay, so this total power requirement is for per hour requirement. Now at the end, what we need to do is you need to find out what's in how much water is being pumped per hour itself. Okay, so to do that, it is nothing but volume of water being pumped divided by the rate of pumping. So that is nothing but 4 million liters divided by 1500. So into divided by 60, when you do it, it will be converted in terms of hours. So you'll have 44.4 hours. Okay, so when you multiply this 44.44 into that, how much power you got per hour basis, so that will be around 1476.9 kilowatts per hour itself. Okay, so now what's the cost? This cost is been given per watt itself. Okay, so what we need to do is this value into 0.025, that is been already given in the problem itself. Okay, so the power cost 0. Sorry, 25 paisa per kilowatt. So that is being multiplied with here itself. So you'll have the value around 369.23. So this is the cost of electric energy over here. Okay, so this is all about that first problem itself. So now going to that second problem itself. So what has given in the second problem is that key what's the water has to be supplied to a town with 1 lakh population at the rate of 150 liters per capita per day. Okay, from a river away, that is 2000 meters. The difference in elevation from the lowest water level in the sump and the reservoir is 36 meters. Please remember these points. Okay, if the demand has to be supplied in 8 hours, because normally we take it at 8 hours, because normally the labor timing will be 8 hours period, the man who is working in a pump station. So you need to pump the total quantity of water within that 8-hour duration time itself. So now what I said, determine the size of the main and brake horsepower of the pump required. Assume the maximum demand as 1.5 times. Why 1.5 times? That you can see that in variation demand. Okay, so there will be variation, right? So you have to satisfy to the maximum variation also. So for that reason, we take around 1.5 times an hour average of that average demand itself. Okay, so assuming f equals to 0.005, okay, and the velocity of the pipe is around 2.4 meter per second, and the efficiency here is 80%. The pump efficiency is around 80%. So first, when you need to find out the horsepower and all, first you need to calculate the capacity. The Q you need to calculate first, then you need to calculate the H over here. So first what we are doing here is we are calculating Q first. So for the Q, what we required is we required population, and we required what is the per capita demand. So that is 1 lakh population into 150. So you can see 1 lakh population into 150, that will be around 1500 million liters per day. Okay, so now this one need to be multiplied with a peak demand. So that is being given as 1.5 times. So where it is, the question. So where it went, man. Okay. Here it is. So 1.5 times that of an average demand. So that we are multiplying it, we'll have 22.5 million liters per day. So now, as I stated earlier, you need to supply the water in 8-hour duration time. So the quantity becomes more here. Okay, so for quantity becomes more. So for that, what we need to do is 22.5 into 24 divided by 8. So this much quantity is required to be pumped in that 8-hour duration of time. So now what happens here is, so now this discharge has to be calculated. Okay, that has to be converted in terms of cubic meters. So what we are doing is this 67.5 into 10 raised to 6, that is million liters, divided by 10 raised to 3, that is you are converting from liters to meter cube, into 24 divided by 60. So 24 is the day, 60 is a minute, 60 is a second. So you'll get the value around 0.781. Okay, so you know that the velocity that is already given, that is 2.4. So area will be how much? The area is nothing but that will be q by v. So when you divide it by q by v, you got a value of 0.325. so that is an area of the pipe. So d equals to nothing but under root a into 4 by pi. So when you do it, a is nothing but here 0.35 into 4 by pi under root. Okay, so you'll get in value around 0.43. You are ending up this value to 0.65 meters. So 0.65 meters will be in diameter of that pipe. Okay, next. So he has given that 36 meters. So as I have stated, that 36 is nothing but that is HS and HD. So you need to find HF, that will be your total height. So for that HF, that is nothing but height loss due to friction. There is an equation given as F dash L V square by 2 GD. Okay, so F dash is nothing but 4F. So F is already given in that question itself, that is 0.00 or 0.0075. So when you multiply it by, you need to multiply it by 4. Okay, there he is given F, he has not given F dash. So that point you need to remember. We require here F dash. Okay, not F. Only F he has given. So for that F, you need to multiply it by 4. So that value is around 0.03. So L is already given, V is already he has given, D we have calculated here. So by doing so, what we have done is we have calculated HF over here. So HF is equal to nothing but 27.17. So now what will be the total H? So total H is which consists of HS, HD and HF. So 36, that is already he has been given, plus HF, that is 27.1. Okay, so now what will be in horsepower requirement? So this is equation already is given in the theory itself. So that is nothing but rho W QGH nu into 0.735. Okay, so here the value will be 9.81 into 0.781 into 63.1 divided by 0.8 into 0.735. Okay, so the total horsepower here will be around 822 horsepower. Okay, so this ends the second problem itself. So in this sense, you need to calculate the horsepower of that pumps itself. Okay, so this ends a few problems regarding pumps. So thank you very much. Take care. Bye.